Last day we really just looked at exponents when we were doing chain rule. But of course, to have a function inside a function, we haven't talked about things like trig or the exponential graph. We will also talk about the log graph as well, but and log functions. But these, for some reason, start to give students lots of problems, so we need to practice them as a separate piece. I'm not sure why, but when students see this sort of thing, they don't always see the two functions that are there. So there are actually two pieces, because at the moment, the most common thing that I would get would be cosine 2x. However, this is not the correct derivative, because there's a function inside the sine, and that's 2x. So it would be the sine of the derivative of the outside, which makes cos 2x, times the derivative of the inside, which is 2. So the answer to this one would be 2 cosine 2x. So the next one, if I was to work on that, would be negative sine x minus 1. And the inside derivative, so the derivative of x minus 1, that's just going to be 1. So I have negative sine x minus 1. And the exponential graph, e to the 3x here, again, there's two functions. There's the exponential graph, and then there's a 3x. Right? If we're comparing that to the original, which was just e to the x, there are two things happening in there. So as long as you recognize where the functions are, in this case I'd be dealing with, let's see here, e to the 3x, your favorite derivative, times the derivative of the inside, which is 3. So it would be 3e to the 3x. So why don't you try the next 3 down there by yourself and see if you can get the hang of finding them. So the last one, if you put a set of brackets around it, they mean the same thing. This set of brackets is power rule. So the outside one is going to be 2 times the cosine of x to the first exponent. And now I have to multiply by the derivative of the inside, which is the derivative of cosine. So once I tidy that up, I'd get negative 2 sine x cos x. And this, probably the form we would find, but you should recognize that as an identity. So just to refresh your memory here, that would be negative 2 sine x as well. Why might we want to go to that length? If you had to consider doing a derivative, which one would you rather take the derivative of right now? The top one or the bottom one? Yeah, the bottom one it's just a simple chain rule. The top one is a product rule. It'll probably take more work involved in the top one. So one thing about the chain rule, that if you're doing like your own accounting as you go through this, every time there's a function, there will be one derivative for each of those functions. So when you look at a question, a good way to test if you know you've got enough of the problem done, if you see 3 functions, that means you should have 3 derivatives in there when you do the chain rule. So for example, this one here, I'll rewrite it for you so it's easier to see the pieces. Before I start this question, what I want to do is figure out how many functions do I have. So can somebody give me one of the functions that's up here? Doesn't matter, just, yeah. 4t is one of them? Doesn't have to be in order, just see if you can find them. What else is here? Okay, the cube. What else? Yeah, sine is the last one. So since I see three functions here, that means if I've done it properly, I will have multiplied three derivatives into this. So let's take a look and I'll show you how it would go. It would, oops, sorry, that's pesky spacebar. So it would go derivative of the outside, which will be 3 sine of 4t squared. Now that's one thing I've done. I still have two more to do before I'm finished. So now I can safely, I'll erase this, but I can safely just focus on the inside, right? What's the derivative of that inside piece? Yes, it'll be cosine 4t. Okay, so there's our second derivative, piece number 2. But we're not done because remember we started and the inventory said there were 3 different functions. We have to have 3 different times when we take a derivative. So the last piece that I'm looking for should be, yeah, 4. Because that's the derivative of that last inside function. So 1, 2, 3 have all been done. So that is the proper derivative for multiple chain rules in there. Okay? Okay, so we're quickly running down the set of things you have to memorize, the list of rules, and we're getting there. I promise it's about to end fairly quickly. You'll notice that in this, once we're done this chapter, we start talking about applications. So really, once we get through this piece, we're not going to have, our list is shrinking. So hopefully you're hanging in there. We're almost done going through our list. This is the derivative for natural log of x, and we'll talk here about how to get that. So if I was looking for the derivative, what I'm going to do, and just as a reminder here in case you've forgotten, natural log x, that's the log in base e, where e is, now this is weird, it's Euler's constant. I believe he was Swiss, so I guess that's the Swiss pronunciation. You'll sound silly if you say Euler. But then again, it'll only be nerds that laugh at you, so I guess that's not so bad. So what I'm going to do is, we don't have the derivative for natural log of x, but we've already talked about the derivative for your favorite. So I'm going to rewrite this, so I'm going to have e to the y equals x. And then I'm going to take the derivative of this piece here. So I'm kind of going about this indirectly. So let's figure out what happens here. The derivative of e to the y, this is your favorite derivative, it's still e to the y, but it's going to be multiplied by the derivative of y with respect to x. And on the other side, it's 1. So where did this piece come from? This is the chain rule. It's the derivative of the outside piece times the derivative of the inside piece. So if you prefer, we could also call this y prime. That would be fine too, right? Derivative of y. But I'm using the chain rule here. Because remember, y is defined as something else. It's not just, it's natural log of x. It's not just the variable y. So now what I've got here is I can rearrange this, and I've got y prime is 1 over e to the y. So y prime is going to be 1 over e to the natural log of x, and hopefully you remember that identity there. You've got the base and the logarithm are the same, so that's a function with its inverse. They cancel each other out. So this would just be 1 over x. So that's kind of a clever way to do it indirectly, but until you know the chain rule, you can't really find it like that. And don't worry, for the most part, that sort of cleverness is at the very, very highest end of the scale that you would rarely see it if you were going to be stressing about having to do that or come up with that creativity on your own. Okay, so let's try some logs now. So if you've got the hang of the chain rule, you should be able to do these ones. I'll let you guys have a head start here. So the first one is 1 over x, not 1 over 2x. Remember, the chain rule still applies. But it might be kind of strange, like how is it that you end up with the same derivative? But we can take a look at this from Math 12 that we've done. This is like 2 times x. Do you remember what's the rule for logarithms when you multiply? Forgotten already, or is it just too early? How do you deal with it when the product of two things? You separate them, okay, and then what goes in the middle? A plus, yeah, okay, so you got it. So it'd be natural log 2 plus natural log of x. So when I take these derivatives, that one would be 1 over x, and the derivative of this, that's just a constant. It would be 0. So it is, strange that you end up with the same derivative even though you have a different function, but it is correct, 1 over x. Okay, so hopefully those are something similar to what you have. Hopefully you're getting the hang of the log laws as well. Well, sorry, hopefully log laws are something you're supposed to know, but the derivative of the log. Now, there's sometimes when using logs is like a dead giveaway. For example, I'll show you with the first one to give you a hint, because you look at that second derivative here, see that? That should make you throw up. That would take a long time. If you looked at that, it's going to be like a product rule, a quotient rule, a chain rule, a couple of chain rules. There's a lot of stuff in there. It makes a giant mess. So if you had to do this by hand, chances are you'd make a careless mistake. And if not, it would take a very long time. So this is when you want to have a better way of going about it. How could I rewrite this one using log laws? What could I do instead of square root? Yeah, exponent 1/2. So go a little further with it for me. What else now? What's the log law for exponents? Yeah, move to the front or multiply, right? So this would be the same thing as, 1/2 natural log x plus 1. So by using the log laws here, I've actually removed some of the complexities. I just have a constant times the natural log of x plus 1. So that'll be 1/2 times 1 over x plus 1. And the derivative of the inside is just 1. So I could write this as 1 over 2 times x plus 1. So that's the idea. Refresh your memory about the log laws. You want to pull this thing apart as much as possible before you try and take its derivative. So pull it all into different pieces. You should have a very, very simple derivative to do when you're done. So I'm going to give you a minute to work that one out on your own. So this is as far as I'm going to break it down, pulling those things apart. And that's much simpler to deal with. So what I'm going to do now is take the derivative of all the pieces. So I'll write the derivative in a different color. So 1 over x is the derivative of the first piece, plus 2 natural log x plus 1. That'll go to 2 over x plus 1. The derivative of the inside is just 1, so I would be multiplying by 1. And then I'm going to subtract 1 half times 1 over 2x cubed minus 1. And the derivative of that inside piece is 6x squared. So 1 over x plus 2 over x plus 1. And the 6 and this 2 here, so I'll make this a 3. So it would become 3x squared over 2x cubed minus 1. And again, it's much easier in those single pieces to deal with. Even though that's a complicated derivative, it's the log laws that help you get there much faster. So remember that. If you come across logs, use those log laws to your advantage so that you can find the derivative much easier. So the last part of this is that we be able to find different bases, and that means, you know, something like, what's the derivative of 5 to the x? So here's the generic formula for any base other than e, and it looks like this. How you get there is a to the x. I want to use the information I already know, which is the base e. So if I rewrite this as e to the natural log a times x, then when I take its derivative, it's just going to be, that's like e to the x, and there's that extra constant natural log of a, so it would be a derivative of e to the x times the inside function here, which is just natural log of a. Sorry, I actually have that one. So the example that we gave was 5 to the x, so it should be 5 to the x would become natural log of 5 times 5 to the x. So that's the only adjustment you have to make to your favorite derivative. It's no longer just the 5 to the x. You have to multiply by this constant here, natural log of 5. And then similarly, if you're not in base e, you can get there through change of base rule. So if you looked at your change of base rule, that'll give you a different way to get the derivative, which is 1 over natural log. So again, it's this correction multiplication in by a constant. So if we were to try log base 3 of x, it would be 1 over x, just like you normally have, but we'd have to multiply in by natural log of 3. So exactly as we've done it, you just have to remember that that constant belongs there. So give it a try here with 2 to the sine x and log base 5 of x squared plus cos x. Okay, so hopefully you have something similar too. And if you're at this stage of the game, then you're in real good shape, because that basically takes us from top to bottom of the lesson today, which was working on chain rule of functions like sine, cosine, and log, and doing bases other than e. Okay, so we'll finish off today's block with just some practice out of basic skills practice out of your textbook to get some of those things into your mind. And next block we'll talk more about some exam strategies.